In this video, we are going to focus on an extremely important concept in matrices. That is the determinant of a matrix. The determinant is just a single number that we can calculate from a square matrix, and it tells us a lot about the matrix. For example, whether the matrix is invertible. So, by the end of this video, you'll be able to compute the determinants of a 2 by 2 and a 3 by 3 matrix, and you understand some properties of determinants. Okay, so let's start. So the first thing that you should remember is the determinant is defined only for square matrices. Okay, so let's start with a simple 2 by 2 matrix. So let's start 2 by 2 matrices. So let's be looking for the determinant of 2 by 2 matrices, which is a square matrix. So let's say we have a matrix A, which is A, B, C, and D. Then the determinant of this matrix is A times D minus B times C. So AD is at the diagonal. So this is the diagonal. These are the numbers at the diagonal. So we multiply the elements at the diagonal and subtract them from the elements which are not at the diagonal. So B and C are not at the diagonal, but A and D are at the diagonal. So we multiply the elements at the diagonal and subtract them from those which are not at the diagonal for a 2 by 2 matrix. So let's have an example. So let's have a matrix 3, 2, 1, 4. So to take the determinant of this matrix, let's say the matrix is the matrix A. So the determinant of A, so we multiply the elements at the diagonal and subtract them from those which are not at the diagonal. So 3 and 4 are at the diagonal. So we multiply 3 times 4 minus 2 and 1 are not at the diagonal. So we have minus 2 times 1. So from here we just simplify. 3 times 4, that is 12, minus 2. So this gives 10. So that is a determinant of that matrix. So as we can see, this is simply cross multiplication, except that we don't have an equal to sign. It is replaced by a minus sign. So this is simple cross multiplication. So let's have another example. So let's have a matrix 1, 2, 2, 4. So the determinant of this matrix, the matrix is the matrix B. So the determinant of this matrix, we multiply the elements at the diagonal, the leading diagonal, and we subtract it from those which are not at the diagonal. So we have 1 times 4 minus 2 times 2. So remember, this is simple cross multiplication. So we have 4 minus 4. This gives 0. Now this takes us to something. When the determinant is 0, then the matrix is a singular matrix. So when the determinant of a matrix A is equal to 0, then the matrix is a singular matrix. Singular meaning the matrix does not have an inverse. So when the matrix is equal to 0, we can say the matrix is singular, or we say the matrix does not have an inverse. Okay. So let us have another example. Let's say we have 2, 5, minus 1, 3. So let's say this matrix is C. So the determinant of C, we're cross multiplying. So take this times this minus this times this. So here's subtraction. So we are multiplying the elements at the diagonal, the leading diagonal, and subtracting from those which are not at the leading diagonal. So here we have 2 times 3 minus 5 times minus 1. So this is 6 minus negative 5. So this gives 6 plus 5. And this is 11. So that is the determinant of that matrix C. Okay, so all this, it applies only for 2 by 2 matrices. So that formula applies only for 2 by 2 matrices. So we can also look for the determinant of 3 by 3 matrices. So this is 3 by 3 matrices. Okay, so for 3 by 3 matrices, we cannot just do simple cross multiplication. It does not work like that. So for this, we need to use something called the cofactor expansion. So we expand along a row or a column. Okay, so let's have a general formula. So let's say if A is equal to A11, so this one is just the position of that element. A12, A13, A21, A22, A23, we have A31, A32, and A33. So if we have a matrix like that, to find the determinant of that matrix A, we are going to take the element A11 and multiply it by the cofactor A of A11 plus A12 multiplied by the cofactor of that position plus A13 multiplied by just like that. So the minor now is the determinant of the smaller matrix you get after deleting the row and column of the element. So let's have an example. Let's have an example to explain this formula. Let's have a matrix B, which is 1, 2, 3. So remember, in this case, we are dealing with a 3 by 3 matrix. So we have 1, 2, 3, 0, 4, 5, 1, 0, 6. Okay, so this is a 3 by 3 matrix. In a 2 by 2 matrix, we could simply look for the determinant, that is simple cross multiplication. But this is not that case. So here we need to do something different. So we are doing cofactor expansion. So the determinant of B, okay, so from the formula, we take this first element 1 times. So we take this first element. Now we have to delete its rows and columns. The rows and columns which has the element. So we delete its row we delete its column. So what is left? 4, 5, 0, 6. So that is what we have there. That is the cofactor. So we now have plus. We take the next 2. Okay, so here, when doing this cofactor expansion, there is something that we need to do, because this 2 is not supposed to be plus, it's a minus. So when doing this expansion, put something in your head. This is plus, minus, plus, minus, plus, minus, plus, minus, plus. So this one will have a positive value, a positive sign. So this one will be positive, this 2 will be negative, this 3 will be positive. That's why we have minus 2 for a 3 by 3 matrix. So this is positive 1, minus 2, positive 3, and it goes like that. So now that is why we have a minus 2 and not a positive 2. So we take 2. Let me just write back the matrix. We continue with 2. So we take 2, we delete its rows and columns. So we delete its row, we delete its column. So what is left? 0, 1, 5, 6. We write them in the order in which we are seeing. We are seeing 0 and 1, we write it like that. We see 5 and 6, we write it like that. So that is that. Now the next number 3 will have a positive sign. So we have plus 3 now. We do the same. We delete its rows and columns. Let me write it back. So we delete its rows. This is a row, delete the row. Now we delete the column. What is left? 0, 4, 1, 0. And that is all. So now we simplify it. Now let's simplify each. Let's simplify each 2 by 2. So let's have the first one. The first one, this is the first one. This is the first one. So we take this alone, we look for its determinant, and then we multiply by this. We take this alone, look for its determinant, then we add it, and we'll take this alone, look for its determinant. So let's take the determinant of the first case. So we have 4 times 6 minus 5 times 0. So we are cross multiplying. We take 4 times 6, that is the elements at the leading diagonal, subtracted by those which are not at the leading diagonal. So we take that. So this gives us 24. 24. We take the second case. So here we are just simplifying it differently to ease things. So we do the same. 0 times 6 minus 5 times 1. This gives us minus 5. We take the third. 0 times 0 minus 4 times 1. This gives minus 4. Okay, so now we put it there. So the determinant, we plug it back. The determinant of B is equal to, so we had plus 1. We are just putting it back. Plus 1 times, when we had a determinant of that, it gave us 24. 24. And then minus 2. Then we had this, it gave us minus 5. Plus 3. Then we had this, it gave us minus 4. So this gives us 24 plus 10 minus 12. So all this gives 22. So the determinant of this 3 by 3 matrix is 22. Okay, so let's take a second example. Let's say we have A 2 0 1 3 0 0 5 1 1. Okay, so let's do the same. The determinant of A. So before we do this, we need to know that plus minus plus minus plus minus plus minus plus. So this tells you that 2 will have my plus, 0 will be minus, and 1 will be plus. So we are just doing that to know the signs. So since here we are just taking the numbers on this first row, but we can still use this second row as our main numbers. You must not use the first row. Use which is better. So if we use the second row, we have 0 0, so it's going to make things easier. So let's use the second row as our main. So we are going to take 3. So here we see that 3. Here we have 2 0 1 plus minus plus, 3 0 0 minus plus minus, and 5 1 1 plus minus plus. So if we are taking this second row, 3 will have a minus number, so we take note of that. 3 will be minus. So here we have minus 3 times. So we delete its rows and columns. We delete it, this and this. What is left? 0 1 1 1. So we have 0 1 1 1. We take the next 0. 0 is a positive, its position is in the positive, so we have plus 0 times. We delete its rows and columns. We delete. What is left? 2 1 5 1. So this is 2 1 5 1. We take the next, which is still 0, is going to be negative. Negative 0. We delete its rows and columns again. This 0, this, and this. So what are we left with? 2 0 5 1. So that is that. Okay, so now let's take each case and simplify. So we simplify each 2 by 2. So let's take the first one. The first one, we have 0 times 1 minus 1 times 1, which is minus 1. So if we take the second one, if we take the determinant of this case, if we take the determinant here, it's going to be 2 times 1 minus 5 times 1. It's going to give us a number. But if we multiply it by 0, it's still going to give us 0. Here, if we take the determinant here and multiply by 0, it's still going to give us 0. So there's no need stressing. So we just remove this. So all this will give us 0. So we remove it. So all this will give 0. So we leave it out. So this is enough. So we have, let's put it back. So we have determinant of A equal to minus 3 times minus 1 plus 0 minus 0. Because all this gives 0, all this gives 0. So this is just going to give plus 3 plus 0 minus 0, which is just going to give 3. And that is the determinant of that matrix. So as easy as that. So remember, we use the cofactor expansion, and we need to find the signs of each element, like which element has which sign. That is why we put this positive plus minus plus minus plus minus plus minus plus to tell us which element has which sign. That is only when we are doing cofactor expansion. Okay, so we have some properties of determinants. There are some properties of determinants. So we have the properties. So the first property says if you swap two rows, or columns, then the determinant changes the sign. So we can say if we have a matrix this, and let's say it is 1, 2, 3, and 4. So if let's have the determinant. So the determinant is 4 minus 6, which is minus 2. So now if we swap the rows, let's have 3. If we swap the rows, it's going to be 3, 4, 1, 2. That is what we're going to have. We have just taken this up and taken this down. So you can swap the rows or swap the columns. It depends on you. So if you swap the rows, the determinant will just be a sign. The sign will just change. So here we are going to have 6 minus 4, which gives 2. So here was minus 2, here was 2. So the sign has changed. That's the first property. So the second property, if two rows or columns are identical, then the determinant is equal to 0. So if two rows or columns are the same, are identical, then the determinant is equal to 0. Or if one row or column is a scalar factor of another row or column, then the determinant will still be 0. Okay, this is the second property. Let's have the third property. If a row is multiplied by a scalar multiplied by k, which is a scalar, then the determinant will also be multiplied by the scalar. So if a row or column, let's say any row or column is multiplied by, let's say, 2, then the determinant will also be multiplied by 2. Now let's take the fourth property. The fourth property says the determinant of an identity matrix is equal to 1. So let's have an identity matrix 1, 0, 0, 1. This is for a 2 by 2 matrix. The determinant will be equal to 1. So this is an identity matrix. So the determinant will be 1 times 1 minus 0 times 0, which is equal to 1. So that proves the properties. So these properties are useful shortcuts. So if they just give you a matrix and you know its property, then it will be easier for you. So that is all for today, guys. Thanks for watching this video, and I will see you guys in the next video.